Good morning, dear students. You know that in physics we are so confident to define all laws of nature. But you will surprise that number of things we are not able to understand as well as not the part of our course in physics. Just I am taking simple example of walking, running and jumping. And I would like to explain you what the physics is working behind this. You know only superficially that we are pushing the earth and earth is pushing back. As action of reaction we are walking. It is in wake, it is okay. But you have to understand on the feet wearing the shoe. Shoe having number of things. For example, here it is the sole. And these soles having some kind of what? Slots. They are creating some friction. Here we are seeing the high heel. The heel is having the toe. So here the pressure, force per unit area is the pressure. When the area is decreased, the pressure is increasing here. But here area is increased. So what we are seeing, the pressure is reducing. So what we are finding, we have number of things those are working with respect to walking part. Especially our limbs or the muscles are doing a lot of work. And the output, the product of the mechanical advantage and the input work or input force. So here we are seeing the whatever the output is coming always be less. In compared to the input, the limbs or the muscles applying a lot of force which you can't understand. So the reason why it is the output force is less, because the mechanical advantage is always less than 1. Now we are trying to understand. The walking is depending on center of mass also. Here we are seeing the center of mass position is shifting. For example, this is a man holding one child on the shoulders. What is happening? He is now leaning in forward direction. He is leaning now in forward direction. Whereas one student having the bag in which having the some books or his needful things. On this shoulder we are finding he is keeping the bag, but other side he is leaning to compensate the center of mass. Another one we are seeing here, one lady keeping the books in arms. Now she is in the backward direction leaning. So in all these three, what we are observing, the shifting of center of mass matter, and we have to balance that center of mass. We are taking the example of here it is the standing position, the center of mass is here. Now is leaning in forward direction. So what we are seeing, the sprinters at the time of start, they are leaning in forward direction. They are what? Positioning the center of mass, and at the time of running, the center of mass matter a lot. The center of mass, what? Here we are seeing going down, and when he is taking the jump, he is what? From the ground position coming at some height. So automatically the center of mass is increased, or the position of the center of mass is now shifted. Here we are seeing that the body or the leg having compensation of their muscles. For the arms, the biceps and triceps are what? The pair. So always the muscles are in pair because they contract. Here in the legs, two kinds of muscles are gastrocnemius and the quadriceps. The contraction of the gastrocnemius, then automatically you will find the quadriceps what? Relaxed. So what is happening? It is the position when the flexion of the leg. Flexion of leg means what? We are reducing the angle in between the two bones. And then we are finding here the extension of leg. Here we are increasing the angle in between bone. So at this time the gastrocnemius contracts, whereas the quadriceps what? also contracts. It is the position of the muscles at the time of extension, and that was the position of the muscles at the time of what? Flexion. Now we are taking our complete foot, in which what we are finding at the toe. Some forces are acting. When we are walking on this toe, we are seeing what? This is the position. There the body is in the touch, the feet is in the touch with the ground. And from this, the weight, opposite to the weight there is the normal. And what is happening? As we have to move forward, that's why the friction is working in backward direction. So what we are finding here, the support of the weight of the person is depending on what? Number of forces. And the net force of reaction is in the forward direction as moving or running. But what we have to compensate? We have to compensate the retarding forces. So net retarding forces by the person due to the road contact we are seeing in this direction. One more thing is here working with respect to the force, the moment of force, that is the torque. So what we are seeing here, it is the ankle joint. At the ankle joint, it is the part of center of mass, and we are seeing Achilles tendon is what? Creating some tension at this position. It is the contact force, the direction in this direction, whereas the tension is in upward direction. And what we are seeing, when we are finding the position of the center of mass from the force, the law of moment we will apply here to see the position or to see the measurement of the what? Speed. So what finally we are seeing, in case of running, the center of mass is shifting in this way, and now we are taking long jump. What is happening in long jump? It is in long jump we are finding it is the coordination of the arms and the what? Legs. With respect to the arms and legs position or the coordination, they are able to trace maximum range. You are seeing here three kinds of initial taken by the what? Athlete. In first we are seeing the hand, the second the sail, the hitch kick position, the third one. So what's the purpose of this long jump? They have to travel what? Maximum horizontal range. And what? It is the parabolic motion. So here we are defining, it is what? Parabolic motion. In parabolic motion, it is the trajectory. Equation of trajectory is just like the parabola general equation, y is equal to ax minus bx square. And here it is the horizontal range formula, in which the initial velocity is u square sine 2 theta. Theta is the angle through which the person is taking off at the time of flight when taking the long jump or the high jump. So what we are seeing in long jump, when different angle we are evaluating here, 30 degree, 45 degree, 60 degree. When he is taking off 30 degree, he is now reaching here only. When he is taking 60 degree, he is reaching here. And when he is taking 45 degree, he is traveling maximum distance. So when we are using this range formula and substituting the values of theta as well as the velocity, you will find maximum distance traveled by the athlete at the angle of 45 degree. Now we are taking high jump. In high jump, Strel technique as well as Fosdy technique. This Fosdy technique is what? Invented or first used by the what? Dick Fosdy in Olympic of Mexico in 1968. So what is happening here? In these two positions you are seeing, first he is parallel to the what? Bar. He is now taking the body, whole body lean and just like the parallel. And first he is taking one leg and then whole body is what? So finally he is taking other side. In this case what is happening is running and twisting himself, and the back of the body is going, and finally he is coming with the help of what? Back. So these two positions, it depends on the what athlete, which position he prefers and how much perfect he is. So what we are finding, the physics which is working for the long jump and high jump is like this. Similarly, you will find the bamboo. Bamboo jump is what? They are taking one long bamboo and they are fixing at one point after coming with very high speed, and after fixing they are just taking the jump with the help of bamboo and trying to cover maximum height. So what we are finding, after all, this is the physics which we should learn. So dear, whatever the physics we have read, now we are going to see some video clips in which you will understand how the muscles are working, how the takeoff taken by the sprinter and the athlete is covering maximum horizontal range. So let's we watch together. Physics behind walking, running and jumping. Walking or running is not a topic that is usually studied in a physics course, as it is the part of life science in sports. When walking or running with constant speed, no horizontal force is required. We keep pushing backward on the ground to maintain speed. Then body we do not keep acceleration with every stride. Wind resistance is not sufficient to supply the retarding force required to keep constant speed. It's biomechanics.